Don't forget to subscribe and ring that bell.
Hey, I see you there. I'm glad you're back. Maybe you're not back. Maybe this is the first video you're watching from Visca the Teacher. Either way, glad you're here. We are going to do free response question number 1 from the Practice 2014 AP Calculus AB exam. And, all right, giggity giggity, we get a graphing calculator for problems 1 and 2. Okay, speaking of graphing calculators, my class set that I use is the TI-84 Plus CE Color Edition. Those are stinky yellow and gray, they're boring. In the description, I have links for all the cool colors. If you're in the market for one, down below, check it out. Personally, my favorite color is green. I own the mint green one. Yeah, mint is the right word because that thing is awesome. All right, let's start free response question number 1. Number 1 reads, Ruth rode her bicycle on a straight trail. She recorded her velocity, v of t, in miles per hour for selected values of t over the interval from 0 to 2.4 inclusive hours, as shown in the table above. So for t being in between 0 and 2.4, the velocity of t is always greater than 0. Notice they don't have greater than or equal to right there, because velocity, which is this one, is actually 0 at time 0. All right? That's not a big, huge deal, but just something to note. All right. So 1A asks us, use the data in the table to approximate Ruth's acceleration at time t is 1.4 hours. Show the computations that lead to your answer. All right, this is a very, very easy question to do, and I'm glad we're starting with this one. And by the way, if you've never seen any of my videos before, oh, I love tables and charts and graphs. I love them. So let's take a look at this. 1.4 time would be right here. Okay, if I've got to guess, okay, the acceleration. Acceleration is the derivative of velocity. I should make that a t, dt. As a derivative of velocity. Derivative is the same thing as slope. All right? So we really want the slope of velocity, and we're going to use this data in the table to approximate. Approximates, it's approximately, to approximate this value. Now, if we're going to approximate this value, we can't get it exactly. But if I'm going to approximate it, and I've said this a million times, the word approximate, I'm just going to take the two closest coordinates, if you will, to 1.4. And that's 1.2 and 1.6. And I'm really just going to do a change in y over change in x. Now, keep in mind, y would be this, x would be time. All right? So we could say y2 minus y1 over x2 minus x1, or the way our calculus book writes it, we would say v of, I don't know, let's call it b, minus v of some value a, all over b minus a. All right? So I'm going to use 17.2, this, that can be considered like our y2, minus our y1 of 16.3, all over, this would be our x2, our matching coordinate, okay? Got to keep on scrolling down here. 1.2 minus an x1 value of 1.6, okay? Now, you might say to yourself, I have the calculator, Visca. Why am I even writing this on my paper? Because it specifically tells me, see in the top right here, show your computations right above this calculator LCD screen? You need to show how you got it. So alpha, y equals enter. And we have the following values in our fraction, okay? 16.3 minus, oh yeah, I'll be okay. I went the other way. I went 17.2 minus 16.3 all over 1.2 minus 1.6. Okay, and there we go. I want to drag this down here just for the sake of having it. Right here? Yeah. All right, so my answer, all right, it's right here. It would be negative 2.25. Show your computations. That's why we needed this. Okay. Indicate units of measure. First of all, velocity is in miles per hour. Okay. Velocity would be miles per hour. However, this is acceleration, so it needs to be miles per hour squared. A lot more explanation for a very simple problem that you should have been able to do in your sleep. 1B, using correct units, interpret the meaning of the integral from 0 to 2.4 of v of t dt in the context of this problem, which means I'm going to have to talk about Ruth, her bike, miles per hour, whatever, because that's what's given to me in this problem. So after we interpret the meaning of that integral, we are going to use a midpoint Riemann sum with 3 subintervals of equal length from the table to, again, there's that word, approximate this integral right here. All right, so let's start above with, we'll go with that gray little pencil like we're doing this in pencil. Let's interpret this integral, okay? So the integral from 0 to 24 of v t dt, all right? That is going to represent distance, okay? Remember, I have position, I have velocity, and I have acceleration. These are all one derivative away from each other. But if I go backward, that's integration. Right here, I have velocity. I'm going backward, so that's what integration means. I'm going to do position or distance, all right? I have miles per hour, but when I go backward, I'm only going to have miles. So that's important to know as we interpret what this integral is, okay? So this is the distance, all right? Ruth rode her bike, and you could write this a million different ways. But again, they say in the context of the problem, Ruth riding her bike is what this problem is about. Okay, so I've got to include that. So rode her bike in miles, right? Because again, we mentioned miles. Okay, in miles from a time of 0 to a time of 2.4 hours. That to me explains what the integration or the integral means or represents in the context of the problem. Okay, using correct units. So you need to have miles and hours in here, okay? This covers everything that asked of us perfectly. Yes, you could have written it several different ways. This is just one of the several different ways we could have done this, all right? So what I want to do now is to tackle the second part, the midpoint Riemann sum. So give me a second here. What I'd like to do after I pick up the pen I just dropped is I'm going to move this gray writing down so I can see the table. Let's move that down here. Okay, because I want to be able to see this table as I do the second part, the midpoint Riemann sum. And since that's underlined in green, let's start with green. So I need 3 subintervals of equal length. Okay? So notice I go from 0 to 2.4. So that's a distance of 2.4. If I divide that by 3, that's 0.8. So each subinterval is going to be 0.8. So I start at 0 and go to 0.8. That's my first subinterval right there. The next one goes from 0.8 to 1.6. Okay? And the last one goes from 1.6 to 2.4. These rectangles are kind of representations of the area under the curve that we're going to calculate. Now, it's not LRAM, left Riemann sum. It's not RRAM. It is actually midpoint Riemann sum. That means between the 0 and the 9.5, I need the middle value, 11.8. Okay, I'm going to add that to the middle value of my red rectangle, 17.2. And I'm going to add that to the middle value of my blue rectangle, which is 16.8. But do not forget, when I sum up these values, when I add them up, I always got to multiply by my width. Some people call that h for height. I say w for width. The width of each subinterval is 0.8. That is exactly how I'm going to figure this out. And I'm going to put that in a calculator right now. Oh, put down that pen, silly you. Okay, got to get rid of these little orange dots. Delete them. Turn this on. Clear this out. I'm going to take 0.8 and multiply that times my sum. 11.8 plus 17.2 plus 16.8. And if I did things correctly, I should end up with 36.64 as an answer. Okay, so go here, 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 here. 36.64. Approximate. Now, they're not telling us we have to label it, but you know what? It starts out with saying using correct units. So I'm going to put units there. Again, we're dealing in miles. And if we look at what we wrote here in gray, what does it represent? It represents the distance in miles. So I'm going to just put miles there just to be safe. Maybe they need that, maybe they don't, but I'm not taking any chances. I want a 5 on this test, damn it. And you should too. 1C. For time between 0 and 2.4 hours inclusive, Ruth's velocity can be modeled by the function g given by g of t is 24t plus 5 sine of 6t over t plus 0.7. According to this model, what was Ruth's average velocity during the time interval from 0 to 2.4 inclusive? Okay, so if this is velocity right here, and they want that average velocity, they're not trying to get us to find like a change in rates of velocity or anything like that. They want the average value of the velocity. This is the average value of the velocity. In this case, g of t. Okay. Anytime they want the average value, that's an integration. I'm going to integrate from 0 to 2.4. And how do I know that? This is my lower bound. This is my upper bound. It's right here. Of that function g of t that they gave us. That gives us the total distance, but I got to average that out from time 0 to time 2.4, which means I multiply by 1 over 2, the upper bound minus the lower bound. So 1 over 2.4 minus 0. All right? And that's all I really need to show to let the person grading it know where I get my answer from. I don't got to rewrite g of t here. This is g of t. They gave that to me. Okay? So let's go to our calculator. Man, really good thing this is a calculator problem. Alpha y equals, enter. I'm going to put 1 over 2.4 minus 0 times the integral, so that's math 9, from 0 to 2.4 of, we need another fraction here, and our fraction reads 24x plus 5 sine of 6x. Yes, I need to use x in the calculator, not t, over x plus 0.7. Okay, let's make sure I wrote that correctly, because there's nothing worse than knowing what you're doing and you accidentally leave off a number because the calculator didn't type it in or you mishit a button. dx. That looks about right. Come on, and there we go. There we go. So if we did this right, and we did, that's approximately 14.064. I'm going to go out 3 decimal places because a lot of the multiple choice questions go out 3 decimal places. So that's what I'm going to do right there. All right. And again, this is the average value of the velocity. So I'm going to make sure I put miles per hour. There you go. That's 1C. 1D, which is the last problem for this video. According to the model given in part C, is Ruth's speed increasing or decreasing at time 1.3? Give a reason for your answer. Okay, well, this really is a nice, good problem. It's a typical problem to end with, and I love it. So first of all, the model in part C, in case you didn't need part C or you fast forward through it or whatever, that's 24, yep, that's a 4. 24, there's my t, plus 5 sine of 6t all over t plus 0.7. Okay, this is velocity. Okay, I know they call it g of t, but I'm going to say v of t because it represents velocity. So in order to determine whether a speed is increasing or decreasing, we need to look at velocity and acceleration. So I'm going to take this little bracket here. So velocity, acceleration, increasing or decreasing speed. Okay, and it's a lot like multiplication. It's what we call a scalar relationship. If the sign for velocity and acceleration are the same, I am going to be speeding up. If I were to multiply same signs together, wouldn't it be positive, your answer, your product? That's why I say it's like multiplication. It doesn't give me the number. Okay, I can't take, if velocity happens to be a positive 6 and acceleration is a positive 12. I don't say it's speeding up by 72. I don't multiply these. I just look at the sign. Positive, positive is increasing. Negative, negative is also increasing. If the signs are different, okay, if velocity is positive and acceleration is negative, or if velocity is negative and acceleration is positive, then it's a decreasing speed. So again, we need to know the sign, positive or negative, of velocity at time 1.3. Let's not forget, this is our time. And I also need the acceleration at 1.3, and I need to compare their signs. All right? So let's start with velocity. So the velocity of 1.3. I'm going to put 1.3 into each one of these t's. 1, 2, 3. And again, we could use a calculator. Thank goodness. All right? Alpha y equals enter. That 24 times 1.3 plus 5 sine of 6 times 1.3. Let's make sure we have enough closed parentheses, and we do, all over 1.3 plus 0.7. I always like to input in parentheses, all right? So if I do that right, and I think I did, I should get 18.096. Okay, so let's write this right here. That is approximately 18.096. So how do I get the acceleration at 1.3? Well, acceleration is the derivative of velocity. Okay, and my calculator, oh, my lovely, lovely calculator can take the derivative for me as long as I have a value to put into the derivative, meaning math 8. Okay, the derivative of what function? This is the derivative I want to take, the function, I should say, of which I want to take the derivative. Don't find the derivative of it and put that in. Put the function that you want to take the derivative of. That is our 24x plus 5 sine of 6x all over x plus 0.7. Okay? And what value of x do I want to put in there after I take the derivative? What am I plugging in? 1.3. Okay? Without that number for x, you can't get a derivative as an expression or equation. It can only give you the number. I can't put in x squared, and the calculator won't give me 2x. Now, at least not this calculator. So let's hit enter, and we should get 3.761. Okay, that is approximately 3.761. Guess what? This is a positive value. This is a positive value. Remember, speed is increasing, but we need to give a reason for our answer, which means we're going to write something as to why we think the speed is increasing. All right? So let's go here. Let's go with a fancy, nice black. And let's end this on a good note. So first of all, let's answer the question. Speed is increasing at a time of 1.3. Be specific, because the speed might not always be increasing throughout this whole function. They asked us about 1.3. That's what we're going to give them. So speed is increasing at 1.3. What's the reason? Since v of 1.3 is positive, or I write greater than 0, and acceleration at 1.3 is positive or greater than 0. That is it. We are done. But be specific, please. What do I mean? Don't just say since velocity is positive. Say since the velocity at 1.3 is positive. Don't say, well, acceleration is positive. No, the acceleration at 1.3 is positive. Because who knows? Maybe the acceleration at 7 is negative. I don't know. Be specific to what they ask of you. All right? We are done. That was harmless. Well, a little over 20 minutes. My rambling took a minute or two. Don't forget to like, subscribe, ring the bell. And if there's a question you want to see or a test you want to see me do, leave that in the comments. If there's something you see that I teach one way, that you learn a different way that you think is more effective, put that in there. I have no fear of learning something new. And you know what? You shouldn't either. Because you, my friend, are going to get a 5 on this exam. I'll see you for free response question 2. Bye-bye.
Don't forget to subscribe and ring that bell.